Imagine, for a second, a single test that could scan an embryo's entire genetic blueprint. A test that promises to help parents pick the best and healthiest one, free from a whole laundry list of diseases. Well, this isn't science fiction anymore. It's a technology that is knocking on our door right now, and it could completely change how we think about having children forever.
So let's just dive right in with a really direct question. If you had the choice, could you do it? Could you pick the best embryo? It sounds so simple, right? But that one question just cracks open a world of incredibly complicated issues. And to even start to wrap our heads around it, we first need to understand the technology itself.
All right, first things first, let's get into the science. Because before we can really grapple with what this all means, we have to understand the tool we're talking about. And that tool is a totally revolutionary new platform for in vitro fertilization, or IVF.
It's called PGT-WGS. Yeah, I know, it's a mouthful, but it stands for Preimplantation Genetic Testing with Whole Genome Sequencing. Now here's what makes it such a huge deal. Think of it like this. The older genetic tests, they were kind of like spot-checking a book for a few typos you already knew about. PGT-WGS, it's like proofreading the entire book at once. It's looking for everything from tiny spelling mistakes to big plot holes, and it's even trying to predict the overall story. It is a massive, massive leap forward.
So how does this whole thing work? Well, it all starts with an embryo that's about 5 days old. It's called a blastocyst. A tiny sample, just a few cells, is carefully taken from its outer layer. Then, the DNA from those few cells gets amplified. It's basically photocopied millions and millions of times until there's enough to run a whole genome sequence. And what you get at the end is this massive flood of data covering the embryo's entire genetic code.
And this is what makes it an absolute game changer. PGT-WGS basically rolls 4 different tests that used to be separate into one package. You've got PGT-A, which checks for big chromosomal problems, like the kind that causes Down syndrome. Then there's PGT-M, which hunts for single gene disorders like cystic fibrosis. It also does PGT-SR, looking for structural mix-ups in the chromosomes. And then there's the really controversial one, PGT-P. This one calculates risk scores for complex polygenic diseases like type 2 diabetes, and maybe, just maybe, for other traits too. That's a staggering amount of information to get from one single test.
Okay, so we've got this incredibly powerful tech, but, technology never just appears out of nowhere. To really get why it's showing up now, we have to look at the why. What's going on in our society that's creating such a huge demand for a tool like this?
Well, there are a few really powerful forces all converging at once. Global fertility rates are dropping. People, especially women, are having kids later in life. That means families are often smaller and parents are pouring enormous resources, both financial and emotional, into each child. And this has helped create what some sociologists call child perfectionism, tiger parenting. You mix on that with a very real fear about age-related genetic risks, and you've created the perfect storm. A huge demand for any technology that promises a healthy, successful child.
And this quote from the source material, man, it just hits the nail on the head. PGT-WGS isn't just some neutral medical tool. It plugs directly into our deepest, most modern anxieties and hopes about being a parent. It promises to calm our fears that things might go wrong, while at the same time, it's feeding our desire for that perfect child. That is a potent mix, and you can bet private fertility clinics are going to market it hard.
But, and this is a huge but, with this kind of power comes an absolute minefield of ethical questions. The moment you have the ability to read the entire genetic story of an embryo, the simple idea of just choosing a better one, well, it suddenly gets incredibly complicated. And honestly, it's pretty unnerving.
So let's start with a question that sounds simple, but really isn't. We love to think of genes as being either good or bad, but is that really how genetics works? As you're about to see, biology is almost never that black and white.
And this is the perfect example of why it's so tricky. The gene for sickle cell anemia, that's a classic bad gene, right? It causes a really painful and serious disease. But here's the twist. If you carry just one copy of that so-called bad gene, it gives you major resistance to malaria. So in places where malaria is a huge threat, this gene is actually a lifesaver. So is it good or bad? It completely depends on your environment. How do you possibly weigh that when you're selecting an embryo?
And the complexity just keeps piling up. There's this other concept we have to deal with called pleiotropy. It's basically the idea that one single gene can affect a bunch of different traits, sometimes in ways you would never expect. So you might be selecting an embryo for a gene you think is great for one thing, but you could be unknowingly signing up for a bunch of other traits that are not so great. It's like a genetic game of whack-a-mole.
And this is where it gets incredibly real and, frankly, frightening for parents. The source paper brings up this exact scenario. Some genetic research has suggested that some of the same genes linked to high intelligence might also increase the risk for conditions like autism and bipolar disorder. So what's the choice? Do you roll the dice on a few extra IQ points for a higher risk of a serious neuropsychiatric condition? This isn't just a thought experiment. These are the kinds of dizzying choices this technology could actually force parents to make.
And all of this, it leads to the elephant in the room. The very real fear of sliding into a new consumer-driven eugenics. The major concern is that this technology will stop being a medical tool to prevent horrific diseases and start being a cosmetic tool to select for socially desirable traits, things like height, skin color, intelligence. This could end up just reinforcing our worst social biases and create a world of genetic haves and have-nots.
Okay, so we've been talking about the massive power and the heavy ethics, but let's pump the brakes for a second and come back down to earth. Let's ask a really practical question. Does this technology even work the way it's advertised? Is it safe? And does it really deliver on all these big promises?
Let's go back to that promise of selecting for high IQ. What's the actual gain we're talking about here? Well, according to the studies, even if you have a bunch of embryos to choose from, the average gain you can expect from this kind of screening is about 2.5 IQ points. That's it. It's something, sure, but is that small bump worth all the cost, the risk, and the ethical baggage?
And now let's talk about the fine print. You know, the stuff that gets lost in the glossy brochures. First off, the biopsy itself can actually damage the embryo. Second, the cells they test come from what will become the placenta, not the baby. And sometimes their genetics don't match. Third, and this is a big one, we now know that a lot of embryos flagged as abnormal are actually mosaic, meaning they have a mix of good and bad cells. And it turns out, many of these can just self-correct and become perfectly healthy babies. So by throwing them out, you could be throwing out your only chance.
But this next part? This is the real shocker. The most common and established part of this test is the A component, screening for chromosomal abnormalities. You'd think that would definitely help improve IVF success rates, but a massive 2023 analysis of over 133,000 IVF cycles found the exact opposite. Using PGT-A was actually associated with a lower chance of having a baby than just doing IVF the old-fashioned way. That finding throws some serious cold water on the whole premise of this thing.
So, after all of that, where does this leave us? The arrival of PGT-WGS is way more than just a personal choice for a couple in a clinic. It's a fundamental choice for all of us about what kind of society, what kind of future we actually want to build. It really all boils down to this one central conflict. On one side, you have the incredible promise of disease prevention, using this tool to stop horrible genetic conditions from being passed down through generations. That's a powerful and noble goal. But on the other side, you have the road to human enhancement, using the exact same tool to create genetically superior children, essentially turning them into a consumer product.
And in the end, that is the question that this technology puts right in front of all of us. Somewhere between preventing a devastating disease and selecting for eye color, a line has to be drawn. Between helping a family have a healthy child and creating a new kind of genetic inequality. The technology itself might be neutral, but how we use it won't be. Where we as a society decide to draw that line, that's going to define not just the future of families, but maybe the future of our species.